A very good morning to all. I, Sakshi Tyagi, Assistant Professor in Department of Mechanical Engineering, heartily welcomes you all to the Faculty Development Program on Manufacturing and Fabrication of Polymer Composite Boards, organized by HID AICT Idea Lab, Haldia, West Bengal. This one-week interactive program on manufacturing and fabrication of polymer composite boards ensures enrichment of knowledge of faculties through interaction with eminent personalities from academics. The program is of 6 days and will be covering the following topics: aqua and solvent-based polymer preparation, fiber reinforced composite preparation, particle reinforced fiber boards preparation, encave of the product by CNC wood cutting router and CO2 laser cutting, testing of product as per BIS standards. This knowledge sharing session will benefit the individual and the society as well. On visionary end, this program is aligned with vision of AICT, which states to establish Idea Lab, which is elaborately known as Idea Development, Evaluation and Application Lab, hence encouraging AICT-approved institutions for application of science, technology, engineering and mathematics, abbreviated as STEM. This common facility embedded in the institution under a roof will eventually make engineering graduates more creative and imaginative. Faculty as well as students will be enriched with critical thinking, problem solving, design thinking, collaboration, communication and lifelong learning. To grace the occasion, we have with us eminent professionals of HIT. I welcome Principal HIT, Dr. Subrata Mondal sir, on dais. Please honor with gesture of honor. I welcome Officer on Special Duty HIT, Mr. Amal Kumar Datta sir. I welcome Dean School of Engineering, Dr. Tarun Kantijana sir. I welcome Dean School of Applied Science and Humanities, Professor A.B. Vaidya sir. Henceforth, I welcome all HODs and professors from different departments. Now, I would like to request everyone to stand tall for our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मागे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Please be seated. Now please devote your worship to Maa Saraswati by Saraswati Vandanan. Now I would like to invite Principal HIT Dr. Subrata Mondal sir to inaugurate the FDP with his kind words.
Good morning, my dear colleagues. It's a great pleasure to present here in this inauguration functions of FDP under the AICT program and AICT Ideal program. Actually, the FDP program is pretty much important for the teachers because it's pleasure. It's a great pleasure because teachers makes their up-to-date knowledge of this any field. Just we are considering the project now, which is composite material of plastic. Composite material of plastic tool, and I believe that it's build the foundation of the education system to ensure the knowledge. So it's a better to continue this. FB program always runs in any institute. In previous or current education system, faculty development program always based in surface to organize to maintain the quality of education. So I wish the great success of this program, as you will be benefited and you will be aware what you are doing now, what you should do, everything will be informed from this program, and the knowledgeable persons will deliver their lecture to enrich your knowledge and you will be benefited. Thank you all.
Thank you, sir. Now I would like to call Mr. Amar Dutta, sir, to say a few words on this occasion.
Good morning to everyone. Honorable Principal, Honorable Professor Maiti, Professor Ghosh, Professor Jana, and Professor Bose, and all other faculty. What I would say, I am not from the directly from the academic, I am from the industry, but I am here at HIT for last about 1 year. So, a lot of academics are slowly trickling down into my mind, into my heart, and all. So, I'm really enjoying it. So, I remember the days of when I was pursuing physics, my MSc, BSc, MSc days in Delhi University. So, we used to hear a lot of lectures. All of us are saying, trying to find out what's elementary. Everything elementary was being found as composite today. So people were trying to find out what is the most elementary particle in the entire universe. So people were used to look for elementary. And nowadays, I'm really enjoying people are looking for composite. Every day, I talk to the faculties, and everybody is very busy in developing composites, because these composites are today required by the industrial world. I would only say one thing. I'm really enjoying what I can say about all of you, about HIT and all of you here. Going by the recent statistics, the statistics say the government of India has a special recognition for healthy and slow technology. I'm talking about the government of India, which is running this country. Their Science and Technology Department, the Council of Technical Education, the Department of MSME, Government of India, they have identified a lot of talent in teaching. What was perhaps not known to even the very close vicinity around you was not very much known that what HIT can produce other than producing good students, employable students. You have bagged the recognition of an Idea Lab by AICTE after competing with large number of colleges, universities and institutes. This in itself is an achievement. Thereafter, you got the MSME recognized you as a host institute for setting up an incubation center. I mean, not only confining to HIT, but many of the technical colleges around. And day before yesterday, others will definitely elaborate on this. And I mean, actually, when they invited, then there was a kind of a decathlon where about 50 odd projects were submitted, innovative projects were submitted by HIT. I don't think any of the colleges or technical institutions might have done it. And out of that, we have got 7. And Dr. Ghosh was telling me, all over India, MSME are trying to find out certain kind of innovative ideas which can improve the MSME sector of our country. So out of 257 new innovative ideas that they have found out all over India, HIT has got 7 of the HIT's ideas have been recognized. I think there should be a big clap for that. You should recognize yourself that you have a strength in you. So whatever program today we are conducting, because of certain regulations or certain rules, is of course that will be kept on. But you have there's a terrible amount of latent talent in you, latent talent in you. When I discuss with principal every day and other senior faculty members, we find out how to encourage you people and find out the best thing, so that you come from beneath the surface up to the surface, so that you are visible and doing something. So 7 projects and maybe remaining projects which didn't get the recognition, maybe they might have been lost out because government had a limited money, they have a limited number. But remaining 40 odd ideas still are worth becoming into new projects which will pave the industrial sector, which will pave the growth of industrial sector. So my request to you is, have faith in yourself, tell that HIT and its family is very, very powerful. We are no inferior to IIT or any other NIT or any other technical institutes because government of India has recognized you. The body who has been empowered has recognized you, the credentials of HIT. So keep up. We are there to help you out. Come up with new ideas, learn more things, and give back to the society. Be empathetic to the people's cause. Give back to the society. People are talking about design thinking. People are talking about emotional ideas and all those things. Everything comes from when you are empathetic to the cause of the common people, cause of the society. Be empathetic to the cause of the society. You are very talented. Learn things and take HIT forward so that it becomes one of the premier institutes not only in the East but in India. Thank you very much.
Thank you so much, sir, for boosting all of our well part. Now I would like to call Professor Tarun Kanti Jana, sir, Dean School of Engineering, to say a few words on the particular occasion.
So, good morning, respected principal, Mr. Subrata Mandal, Mr. Amol Datta, Officer of Special Duty, faculty coordinators of this ICT Idea Lab, Professor Gautam Bose and Professor Deepdatta Bose, Dean School of Science, Professor Eli Maiti, Head of the Departments of Chemical, Electronics and Electrical, I fancy faculty members from various department and of course the staffs. This is a wonderful initiative of the AICT and HIT joint venture in developing this idea lab. This lab was developed perhaps on 11th April, so almost 2.5 months is gone. And from the very beginning, from the very inception, these two coordinators are continuously organizing this type of faculty development program as well as for the program for the students, so that the facilities which are available at our idea lab can be explored to its full perspective and full potential to justify the very credential or the very objective of this idea lab. I am not going to the details, but this acronym IDEA stands for, ma'am was already mentioned, idea, development, evaluation and application. And as far as this focus of the party is concerned, the acronym is STEM, that is Science, Technology, Engineering and Mathematics. And if you look to the today's participants composition, it really justifies to this combination that there are people from the science, from the technology, from the engineering and from the mathematics. If you think about or take a look about the facilities which mostly cater to the electronics, electrical, instrumentation and of course the mechanical. So apparently it seems that these facilities are confined to this group of people or people or the students pertaining to this discipline. But if we explore its full potential, there is ample opportunity that people from the other areas like chemical, from the chemistry, mathematics, physics, they can also utilize these wonderful facilities and carry out this work. So this today this 1 week faculty development program spanning over from 4th July to 9th July will be an excellent endeavor from the organizer that people from the chemistry, chemical engineering, they will utilize these facilities to develop the manufacturing and fabrication of the polymer composite. So it is not only confined to the electronics or mechanical domain. So those who are working in the applied chemistry or chemical engineering domain, they can also utilize, they can conceive the idea in that domain. But as far as the fabrication of the manufacturing part, these facilities with the help of people, the faculty and staff from the electronics, mechanical and EI, they can assist you so that this idea can be materialized and you can develop the product for the useful purpose. So with this, I convey my sincere thanks and good wishes to all the participants that this particular 1 week faculty development program on this very particular aspect will be extremely useful and your objective will be satisfied. And I would also request that in the coming days, please disseminate the capability and the purview of this Idea Lab so that more and more number of faculties all across the institutions and of course the various different students from the different other branches also participate and explore these facilities for the product development. Thank you very much.
Thank you, sir, for your informative words. Now, I would like to request Professor A.V. Mani, sir, School of Applied Science and Humanities, to say a few words on this particular occasion.
Good morning, everybody. The respected sirs of the dais and my colleagues, deputy staff, students. Really, day by day we are very growing with fast way. That starting from the 1.5 years back from the consensus level from the Idea Lab, 2000, mid-2000 around July, August, the government of India they confirm our participations. It's a very tough game because personally I have attended one meetings in Delhi. I know what is right. So the Bengal only two institute in the recognized in the center of the ICT Idea Lab, and it is very short span. They not only do the trainings of the different persons, meaning the industry, administrative staff persons or the technical staff person or the faculty of different department in different areas. Like what is today's this week programs like polymer material fabrication board. So they are continuously engaging, and this process, I think in the coming day it will come in a better way. And what is the most striking point I personally feel that at HIT we have a lot of the resource persons. Maybe the physics domains, electrical domains, or the chemicals, or the chemistry, or the physical domains. But this platform, they are exploring their inherent talent and they combining as a team just to exhibit their idea how can we make it the product. I should personally be very happy in the coming day in this ICT Idea Lab. It is now it is gradually becoming a different, very promising center. And for that, I personally want to thank Professor Bose, Institution Department, and the Professor Bose in the Mechanical Department, because they have seen personally, they put in just so much time just to how to design the programs, how to execute the program like so. So without their continuous engagement, it is not possible. And another thing I want to share what already shared by the Mr. Doctor, that this initiation not only enriching the ICT Idea Lab, the institute also getting the recognitions from the different government research body. Because probably you know, all agencies should be very happy that this institute giving the same project, and they already recognize this is a center of the medium small scale industry. So and that project also will span the biotechnology, technology, chemical engineering, with the chemistry or with the others, with the mechanical, instrumentation, information technology. It is joint thing, and that I personally request all our faculty members, you have a lot of potential. Please try to execute what you are thinking today and how that idea can be converted into a product form like this. So please come out and let us see in the coming days how far can go. I am quite optimistic. Now I am quite optimistic because last couple of months, maybe more than 1 year, actually is very unhappy that we have so many faculty, so many PhDs, but very few numbers of projects. Now the initiations have already started. Gradually it will be more and more. So with these few words, I will just end this speech.
Thank you, sir, for your kind words. Now, I would like to welcome Coordinator AICT Idea Lab, Dr. G.K. Bose, sir, to say a few words.
Good morning. I welcome you all to this FDP program, AICT Idea Lab. So, respected Professor Dr. Subrata Mandal, our principal, Mr. Amol Dattu sir, OSD, Professor Dr. Tarun Kanti Jana, Dean School of Science, School of Engineering, Professor Dr. A.B. Maiti sir, Dean School of Applied Science, all the head of the departments, faculty members, and my dear colleagues. So it is a great occasion that we are continuing with our endeavor in conducting faculty development program as a part of AICT Idea Lab. So first of all, I would like to thank my co-coordinator, Professor Devdatta Ghosh, and side by side I would like to also thank Professor Piyush Khatua sir. We are planning for quite some time what will be our next FDP program after we have completed the previous one in the month of June. Now at that juncture, Professor Khatua gave us this idea of development of polymer composite board. So we quickly got into act, and we thought that it might be one of the activity which can be incorporated in the Idea Lab as a faculty development program. Now since this Idea Lab is also a part of STEM, so we took this opportunity to organize manufacturing and fabrication of polymer composite board under the banner of Idea Lab, where the faculty members will be trained to develop, manufacture polymer composite board right from the scratch using the basic raw materials, and the techniques will be taught to them so that they can have a hands-on experience in building and developing this polymer composite boards. And finally, with the developed composite boards, they will fabricate by using various mechanical equipments like CO2 laser cutting machine and CNC wood cutting router, where various profiles, various contours can be developed. So it's a complete manufacturing package which the faculties will be exposed to, and the hands-on experience will also be of great help, so that in future they can always share their experience to their students. As an educator, the real feel of developing a product will be of immense exposure to the faculty members, because we know the kind of tight schedule the faculty members have when the semesters are ongoing, and at the end of the semesters when they have some breathing period. So this kind of programs will help them to enrich their knowledge domain as well as help to venture out in different technical skills set, which also will help them to educate their students and make them aware of the new technologies which are available in the market. So the Idea Lab, as you know, is one such kind of I'll call it a workplace where latest technological machineries are well equipped with the new methods of working are adopted. So the faculty members who are associated with this Idea Lab for quite some time, using their innovative ideas, they are preparing various working models, as well as they are also assisting their students in
completing their projects. So this year, many of the final year projects has been accomplished with the help of this Idea Lab, and more such projects are in the pipeline. So with this Idea Lab, it will not only help the faculty members as well as the researchers who are working in the different domain, and it will always help in developing or inculcating the new ideas, new work they are associated with. So it will be of great help. So finally, I will thank all the participants of different segments of engineering and science domain for actively participating and registering their names. So this faculty development program is basically restricted to the chemistry domain of School of Applied Science, because in near future we will be having a training program to the industry persons with the knowledge of this development and manufacturing of polymer composite board. Will be giving the training to the industry persons who are associated in this domain. So for that we require a large workforce, and for that we have organized this faculty development program to train and gain experience in this field of manufacturing polymer composite board. And I look forward to have this faculty development program a great success. Thank you one and all. God bless you.
Thank you so much, sir. We have Radha ma'am with us. We welcome Radha ma'am, Dean School of Chemical Engineering and Biotechnology. Ma'am, please say a few words on the occasion of FDP inaugural session.
Very good morning to our principal, Professor Mondal, all deans, Professor Jana, Professor Maki, and our honorable OSD sir, and all the present HODs and our basic participants. I am very much proud that the coordinators, Professor Bosch and Professor Bosch, all organized such an interesting area for the APP program, that is the manufacturing and the fabrication of the polymer composite board. Membrane is a very interesting field and essential for the gas separation, liquid separation, and these purposes. And I know that in our department also polymeric membranes are works are going on the polymeric membrane, and I am competent on the ceramic membrane especially. I had worked on the ceramic membranes and preparation and application in the various fields for the separation of protein purposes, for the separation of various contaminants from the effluent water or wastewater. So I believe these areas very much interesting and beneficial for all the participants, and this program will be very much successful because the content is very good. Thank you all. I wish the very successful discussion and the completion of this program. Thank you.
Thank you so much, ma'am. Now I would like to call Dr. Piyush Kanti Khatwar, sir, Professor, School of Applied Science and Humanities, to say a few words on utilization of fiber reinforced composites as panel products for forest reserves. So please. I would like to request all the dignitaries to settle down guys, and we'll start with the presentation by Piyush Kanti Johnson.
So in the meantime, I want to tell you something about the Idea Lab. I will not talk about much on this faculty development program. But this AICT Idea Lab has two purposes. One, this is revolving around different programs, different events. Till now, we have organized, taking this into account, two MDP programs, one skilling program for the students. We have a plan to organize many other skilling for the industry people, and this is the prerequisite MTP for the industrial workshop, because we have a plan to organize one professional skilling program in the month of August with the resource person who will be trained in this faculty development program. So the idea of faculty development program is to enhance the number of gurus in AICT Idea Lab. AICT has taken the initiative to train four gurus from our college. Now, subsequently, with the organizations of different faculty development program, we will be increasing the number of technical gurus. Secondly, we have to think about the program development, a kind of pre-incubation. We have to think in the AICT Idea Lab. Otherwise, after the project period, we cannot go with this laboratory because it involves with lots of cost. So we have to come up with some scheme with our internal revenue generation. We have started getting little bit, interest from the industry. We have to increase it, we have to enhance it so that we can continue this activity for the coming days. Second point which I want to mention, this year is found to be very great for the Institute of Technology. We have got many things I want to share. I want to share it from this forum. We have got AICT Idea Lab, as all the speakers have mentioned, and it is already in place. Apart from AICT Idea Lab, we have got a skilling program. Only 5 institutes across India has got this particular recognition. It's called AICT Korma program, and we are working out to give skills to different segments of the society. So this is one of the recognition we have got from AICT. Secondly, we have got AICT SPICE program. They have given a grant of 1 lakh, a matching grant of 1 lakh to mechanical engineering club, and they will be they are open to associate 2 more clubs of the institute. So this is another recognition we have got it from AICT. Another foremost important, which I must have to mention, in 2020 we have applied for host institute under Ministry of MSME. Got the recognition. After that, everything, because we have participated in the Idea Challenge in 2020. We could submit 20 projects at that time. But after that, COVID came and everything was missed. Then in 2022, at the beginning, they have renewed our status as host institute. Again, they have organized MSME Ideas Hackathon 2022. All the faculty members, most of the faculty members have participated fully. Beautiful teamwork, and we could submit 50 odd projects. And day before yesterday, we got the result. We are the only private institute in West Bengal who have got 7 projects. You will not find any other private institute who have got this recognition or this acceptance from the NSA. And I must mention the name of the faculty members, right? Everyone has participated with 100% effort. Okay, some are considered, some are not. I request those who are not considered, WBDST, under that, still they are organizing one event, but take a thought. Till the date is open. It is open up to 15th of July, I guess. It is extended from 30th June to 15th of July. So I request each and everybody, those were not considered by Ministry MSCB, you can change your idea a little bit. You can just augment some of the points and resubmit it to West Bengal DSC. This is my personal request because when we tried to join with MSCB, we have not joined with very optimistic ideas. We just joined very casually. Slowly, we have got lots of inspiration from the MSCB TI Kolkata. Now, finally, this is the result in front of you. I must mention the name of the faculty members who were the principal investigator. We have got 7. And here you can see Piju Shanti Khatwa. You should get a clap for this. Piju Shanti Khatwa, Radha Das, Professor Turun Kanti Jana, Siddhartha Samanto, the 4th one. 2 more faculty members are not here. Mukesh Singh, Professor Mukesh Singh from Biotechnology and Shati Rai from Food Technology. These 6 plus 1 outsider. Today itself we have contacted him. He is Rishikesh Rai from Kuch Bihar. He is not our student. But I don't know with which aspiration he has applied for our institute. So he has agreed to work in the incubation center we are going to set up here. So this year is found to be quite good for HIT. Let us go with full strength. Thank you very much.
Thank you, sir, Professor Devdatta Ghosh, sir, for coordinator HIT ICT Idea Lab. Now I would like to call Dr. Piyush Karthik Khatwa, sir, Professor School of Applied Science and Humanities.
Good morning, everyone. Actually, nowadays, what is the situation? We are passing through a critical position. Why critical? Actually, our maximum rainforest in tropical zone. You know that there is Malaysia, Sri Lanka, and other country. There was so many trees. The rainforest was there, but due to the demand supply was so less, maximum rainforest was cut off, and it is frequently going to destroy. So in this situation, with the scientists, we always think what will be the substitute of wood. Metal is never possible to substitute a wood and wood-based panel product, because metal, when we prepare, huge amount of energy we should require for in metallurgy purpose. So we think that which are fast growing renewable resources. In our country, Mother India gave us so many fast growing renewable resources. You know, which is called golden fiber, which is too much faster growing bast fiber. Not only jute, bagas, sanem, so many fibers are there. So scientists thought that if we consider this fiber and make it with some polymer to the composite form, so it will be a good substitute of wood. Not only that fiber, some particles also we are utilizing nowadays. And you can believe in front of your desk, maximum bench is made of our particle board, which is laminated with a paper. Now, here, what we should do, we need fast growing renewable resources, means one is adhesive and another is reinforcing agent. So we call that composite. So composite, to prepare, we need some adhesive and some reinforcing agent. Let us consider this concrete. This building, you said just think, here cement is present and we have prepared some reinforcing agent by metal rods. We bind it. It is the reinforcing agent. In our body, our skeleton is the reinforcing agent. Binder is muscle and blood and some other materials. So to make composite, first we need our polymer adhesive and reinforcing agent. Slide that change over, sir. Sir, slide that change over.
Original processing that change. এটা করেছিলাম আমরা কখন চলে যাব স্লাইডস এবার
Next. Now, what is polymer? Everyone know that in Indian sector, everyone know that polymer are high molecular force. It is chemical compound, abundantly available in nature, and we can prepare by synthetic method, artificial method. So, this polymer has a property. It is macromolecules. Macromolecules, and it have a adhesive property. But polymer characteristic is somewhat different. Some polymer are water-based and some polymer are solvent-based. So we will discuss later about the water and solvent-based polymer, what is the advantage and disadvantage. So polymer, mainly macromolecules, we prepared artificially by chemicals or it is abundantly available. Rubber, you know that rubber is natural polymer, so we use that. It is at our matrix, means main binder. It is polymer. Now, what is extender? Polymer normally we prepared in low condense type. Low condense means if we prepare polymer in high condense means higher molecular weight. So it is long chain is formed. So when we add it as binder, then binding is less. Means it form a long chain among themselves. So it is very difficult to form bond with other fibrous material, wood, another fiber. It is very difficult. So we prepare polymer low condense form. But in low condense form, polymer are very flow time is very less, means it is in liquid form. So when it liquid form, when we use in wood or other fiber, so every fiber have pores, so polymer can enter in the pores. As it enters pores in the pores, so we need more polymer. So it is not economically viable. So that is why we are using extender. Extender not only build the viscosity of the polymer, as well as it increase the volume also. Suppose in plywood panel industry, they use different type of polymer: phenol formaldehyde, melamine formaldehyde, urea formaldehyde. There are so many thermostatic polymer, polyester, epoxy. Normally they use extender, moida. You know, it is a good material, and abundantly use moida. You can imagine Century Plywood. It is the pioneer of plywood industry. They are using every month 200 tons. Can you imagine 200 tons of moida for this purpose? Because to increase the viscosity. So it remains in the surface of the layer, so they can bond fine. It is economically profitable, so moida is there. So this is extender. It not only stop the pores of the wood, as well as it increase the volume, so cost is viable. So this is extender. Now what is glue? Glue means when polymer, direct polymer we never use. We never use direct cement. We use some sand, stone. So in polymer, we increase the viscosity in a certain level. That is why it can economically viable and it cannot pass through the wood. So we call that is not polymer, it is called glue. In Bengali we say it is akha. Means it cannot penetrate through the pores. It is the glue. So glue is commercial touch when polymer low condense, because we have to bond with the fiber hydroxylic group, fiber carboxylic group with that polymer. So low condense, but viscosity we increase, that is called glue. Now polymer types. Polymer normally two types. We are preparing for industrial purpose. One is aqua-based polymer, means water-based. Another is solvent-based polymer. Aqua-based polymer is abundantly used in the fiber board, normally jute, wood particle, some hemp, another fiber is bagas means acacia, bagas. So many fiber we are using because they have hydroxylic functional group and carboxylic functional group. So from this functional group joined with the polymer make a tremendously strength bond. So these are aqua-based. Aqua-based polymer normally we use phenol formaldehyde. After formation of strong bond, it is called bakelite. You know, urea formaldehyde. Urea is low cost available in the market. So urea formaldehyde. Melamine, it is we prepared from the urea. So melamine formaldehyde. There are so many such type of polymer, and we can mix with urea, melamine formaldehyde, phenol urea formaldehyde. So these are aqua-based polymer. Solvent-based polymer. There are so many solvent-based polymer out there. You know Fevicol. Fevicol is aqua-based polymer. It is polyvinyl alcohol and our acetic acid. If you just condense it with a temperature of 90 degree to 120 degree, you will get Fevicol. It is polyvinyl alcohol. That is why Fevicol. So these are aqua-based polymer. Now solvent-based. Solvent-based polymer, very good strength property. And these are mainly polyester and epoxy. There are so many solvent-based polymer we are using because when the fiber is non-polar character, they are solvent-based polymer interact with them very nicely. Polar interaction is very good. Polar functional group present in the fiber, they react with the aqueous polymer nicely. But solvent-based polymer, they are non-polar type and they make a good bond with the our non-polar. Suppose fiberglass. Fiberglass is available in the market. It does not make good bond with our aqueous resin because one is polar and another is non-polar, so interaction is not good. So for fiberglass and other non-polar, we should use our solvent-based polymer. Now, drawback of solvent-based polymer. There are so many drawbacks of solvent-based polymer because you cannot imagine. Suppose paint industry, maximum paint industry you see that either Asian paints or Barja nowadays they are preparing aqua base. Water is mixing. You can tell it is alkyl based polymer, alkyl based PVC based polymer. But solvent based polymer, if we use solvent after paints used, huge amount of polymer, just raw polymer, go to the atmosphere. Let us consider. You just buy a oil-based paint from Asian paints. You use carbinol. Somebody use acetone. Somebody use alcohol. So raw alcohol, raw acetone, raw turpentine, everybody use in the paint, and that remove in the atmosphere. So our atmosphere become polluted by this unwanted gaseous material. But aqueous polymer can never pollute because after drying there is cross-linking takes place. After drying it release only moisture. So these are, that is why in when we are child we never see aqua-based polymer of Asian paint. So oil-based, we paint wood and metal by oil-based. Nowadays for building purpose we are using solvent-based. You see some water is added with that base material and stainer is there and we paint our building aqua-based. That is the advantage of aqua-based polymer. So aqua-based polymer normally polymeric based aqua-based paints. Now we will discuss during our preparation of phenol formaldehyde resin how we can prepare. This phenol formaldehyde procedure I will supply to everyone of this program. This phenol formaldehyde is commercially we prepared, and this is method where this resin you can keep it for 3 months because after resin preparation we send this resin to the other factory. So time is necessary for the transport. So if we prepare resin, it can withstand 3 or 7 days. It is not viable. So this is the method we are using. You can keep this resin for 3 months, more than 3 months. So this is the method we will discuss during the preparation of phenolic resin. This is phenol formaldehyde. Phenol formaldehyde resin are two types. One is resol, another is no-color. Resol means if phenol concentration is more with respect to I am giving the gist. If phenol concentration is more than formaldehyde, then it forms our no-color. But if formaldehyde is more, phenol is less, then it will form the resol. What is the difference? Now, the resol form tremendously strength of bakelite. Suppose pressure cooker handle, you will have seen it is a brown black color pressure cooker bakelite handle. It is very strong. Whereas these laminates, this paper on your seat bed, you see where book are keeping here. These laminates, this paper where we are using phenolic resin, but it is we can fold it. So for flexible, we need no color. No color means simple linear chain. There is not such cross linking. But phenol formaldehyde is more. Methyl linkage is more. So if methyl linkage is more. So there will be cross linking takes place among the chain. That is why it becomes hard. What we have seen in pressure cooker handle. You have seen it is too much brittle and too much hard. So this is difference between no color and phenol bakelite results we will discuss during the resume preparation, and you will prepare with me simultaneously. At that time, it will be clear. In the same way, melamine formaldehyde we will discuss during the preparation. Melamine is prepared from our urea. 3 molecules of urea, just 3 molecules of urea make a chain, it is called melamine. Same procedure I will discuss. Urea formaldehyde in the polymer, actually for low cost, urea is available in the market, 10 rupees or 15 rupees. Whereas phenol is more than 130 and melamine is more than our 240. So melamine, this you have heard the name. Melamine is a fiber. So we can prepare this is. The fiber also are plastic, but basic difference, why it is called fiber? All plastic called fiber when you can make it thin and thread. When we can prepare a dhaga, suta, that means it is capable of fiber, so it is called fiber. So melamine is we can prepare fiber disc as we can make it thin and threaded. Now composite. So our main target is composite here. Composite, there are 2 parts. It is a homogeneous mixture of reinforcing agent and our adhesive. Adhesive we call matrix, and the reinforcing agent normally we use different type of fiber. Maybe natural fiber, maybe synthetic fiber. Natural fiber, abundantly available in jute, bagas, sanhem, coir means narkel, coir, and banana fiber also there. So we can use this fiber. These fiber have huge strength because they are maximum have hemicellulose part. So these hemicellulose have more strength than cellulose, and with this fiber we can prepare the composite. One part is natural and another part is our chemical. So we consider if 50% if they are natural part, it is biodegradable because bioorganism can enter here. So these are composite. You can think that natural composite, wood is a natural composite. Wood log is a natural composite because wood log have fiber, cellulosic fiber, and there is lignin. Lignin is the binding agent. Lignin means it is meta position have a long chain phenol. This is wood. So wood is a natural composite. From our ancient period, we have seen composite is prepared by when they prepared ancient people prepared bricks. That is also a form of composite. So these are composites. So composite have 2 parts. One is adhesive part, another is reinforcing part. Reinforcing part withstand the strain, and adhesive part is acts as binder. Why fiber reinforced composite are important for the survival in future? Due to the demand, we need huge amount of wood-based material. But with demand, our nature gives us the limited wood and wood product. And wood, if we collect from the tree gives us a sufficient wood after 15 years or 20 years. But in these 15 years, 20 years, we need 1,000 times more than the wood is available. So how we can solve this problem? It is possible if we prepare composite material from fast-growing renewable resources. Fast-growing means bamboo. Can you imagine? If you see in your house bamboo, in per day 1 feet increases in Bengal, and in Assam some bamboos are there. Per day 3 feet it increases. So it's a fast-growing. In a particular place where you can plant a sapling, and after 20 years you can get a tree. In that place, if you plant some bamboo, in these 20 years, you can get 20 times or 30 times more cellulosic material because it is a fast growing. Per day here in our Bengal, if you see 1 feet increment of the bamboo, so it is fast growing and long fiber cellulosic material. Jute in 3 months it can mature. So jute, we are ignoring it. But jute is called golden fiber, really a golden fiber. Within 3 months, we can get a huge amount of fiber material. We can make the materials like bench, table with this because we have to fulfill our demand. Now, these are that is why for survival, because we have to save our forest in any cost, we have to save our forest. Forest is the lungs of our earth. So if we destroy it, so we will not more in future. So we have to think for the composite material. This is very important for our survival in future composite material. What is nano composite? I have already told you there are main raw material, main two raw material. One is polymer, another is reinforcing agent. There may be extender, there may be filler. Filler means which fill the hole. But if the reinforcing agent is nano structure, what is nano? Nano is nothing. Nanometer means 1 meter means 100 centimeter. Nano means 10 to the minus 9 order. If it is 10 to the minus 9 order means it's meter, so then it is surface area will be more. Suppose I have a stone, this is time. So if I dig into the small particle, so surface area open means with binder bonding will be give us more strength. But if I give the nano structure, then it will fine powder. So fine powder with that, it will give a tremendously high strength. So that is why if our reinforcing agent is nano structure, nano diameter, then it is called nano composite material. In protective coating in metal, we are using nowadays protective coating, which is nano structure, because nano structure is so tough and cannot break. Different composite material: metal matrix composite, ceramics matrix composite, and our fiber reinforced matrix composite. With demand, metal matrix composite. You have seen, sir. You have seen steel is cutting by a saw. How it possible? Steel is tremendously high strength. A saw is cutting a steel iron. How it possible? You have heard the name tungsten. Tungsten we use in the filament. Its melting point, can you know that it is more than 2000 degrees. So tungsten, if we mix with ceramics and polymer, then this tungsten we just use as a tip on the surface of the saw. Tungsten carbide tip, you have heard the name. So it can cut the steel also. Tremendously high strength tungsten. So this is metal matrix composite. So we are using normally in saw and in the engine, combustion engine. Internal combustion engine, there is huge temperature. So jet, where the fuel is injected, so jet become heated, it become melt. So there we use also metal matrix composite. We are using this. This is metal matrix composite. Another is ceramic. You have seen in the electrical line, the electrical engineer, you have used normally ceramics means our China clay with some polymeric materials for the electrical insulator. In electric line, high voltage electrical line, a brown color ring is there. It is mainly China clay and some it is called particular type of phenolic polymer is there. I just remember that they are using that, and for electrical insulator they are using ceramic matrix composite. Aluminate silicates are also silicon carbide, and finally fiber reinforced composite. Fiber reinforced composite, already I have told you different type of fiber wood particle we are using, and there we mix some extended pillar for our daily purpose we are using. Our table, our desks, our nowadays our bed also we are preparing from fiber reinforced composite. Maybe particle, maybe some fiber. Nowadays we are using composite material. Door also. Solid core composite. Composite are three types. One is solid core composite. In plywood, in this particle board, these are solid core. There is no gap. So you see what is the arrangement of, because composite when we prepare we have to think about the strength. If we use, this is our fiber here. Suppose my finger is the fiber. If I use this is one of the layer of fiber, fluid fiber. Another layer is fluid fiber here. So you can see after the board preparation, the fiber will be weak in this position because when I fold it, it will be plain. So when we want to prepare a composite, we have to keep the cross position. You see the picture? One fiber ready at the east to west, another is north to south. Because all direction it will give the strain. So alternate direction. So to get a composite material, we need the odd number. 1, 2, 3, 3 layer, 5 layer, 7 layer. We are using layer. This is type of. This is called block code. Block code normally we use for the separating purpose. Block code means similar any wood which is not non-usable wood. We can pass through a planar machine. So if whatever it the height, it give you 1 inch means 1 inch. So you just give a fiber, then cross fiber, then you just put this block 1 inch, 1 by 1 by 1, then another root fiber, 2 inch, 2 mixed fiber, and a base fiber. Then you will get this block. These are solid product, and this is very fine. This fine is not color. If you just take the base grain, tomorrow we will practice it. If you just put it in the hot place with the temperature high, then carbonization takes place. It is low heat, so it is less brown. Which will give the more heat. It is deep brown. So after heating, moisture will remove. It becomes carbonization takes place. It is called carbonization. After carbonization, you will get this. So these are different kinds of plywood. Now follow. I have got my project. This MSME. You know that toilet door, plastic toilet door, you know that is minimum 2,000 rupees cost, right? And maximum 10,000, 20,000 depending on the quality of plastic. Here, actually this is called honeycomb. This frame is necessary. This frame for hinges, screw, and latch, we need this frame. But inside we are using here honeycomb. This is called hollow product. My project that I have got from MSME, I want to give a product to the poor people because in Swachh Bharat Mission, every people in the rural area, they are getting the toilet cost, but there is no food. If you go to the village, you will see they are hanging some jute, ganivet, jute, or some corrugated tea. It is not good. So bathroom should be safe. I want to prepare jute, bakelite with hollow core type in a special design. I have prepared that, but prototype. I have seen it is too much less cost, not 2,000. It will be completed, I think, for the poor people. If decoration is not there, within 700. So I have got this project now. So this is hollow core type, and there are so many diseases. If root fiber is there on the surface, when it will cover, you cannot find. In this door, what materials are present in there? This is not a whole wood. Some blocks are there. If you cut it, you will get some blocks, and from both sides, the linear is pasted with the resin. And this is particle. Particle board means the wood dust available in the sawmill, the fiber, any type of fiber, the grass fiber, if we just beat it with a beater machine, small fiber, then we can dry it, remove the moisture. After moisture removed, we mix with glue and make it a hot press. I think tomorrow we will possible to prepare such type of particle board. In my laboratory, there are so many particle board. I will show you this type of particle board. But what is happened? If we use some paper like this particle board, it is covered with the paper. Inside there is particle. It is not wood. This is particle board. It is a laminate sheet giving there, and with the adhesive, you will get a wood-like material. So it is a substance of wood. This is particle board. So particle board, 3 types of we have seen. One type is solid core, another is hollow core, another is particle board. Yeah. These are available in the fiber, any fiber. You just glue it, remove the moisture, then make it a with particles. But moisture is very dangerous for this because in the hot place there is huge pressure. You can imagine the pressure is 10 kg per centimeter square. In this, if moisture is certain level more than that, moisture is present more than the certain level, then at high the press, immediately some like bullets the steam will spray and start up. So moisture we have to control. It is if you control it is 8% to 10% or 6% to 10%, there is no chance of disturbance. For particle board, here we are using 3-layer particle. 3-layer means suppose we want to prepare a particle board. For this paper lamination, the surface should be smooth. Surface should be smooth for paper lamination. So in a steel plate, we are using a very fine layer of particle, root particle. Then we can use a rough particle, large like that, and then fine layer. This fine layer for the smooth surface we can bind the paper. So this is called 3-layer particle. It is a side view of particle. These are laminated particle. You have seen in your base. These are laminated. Just only a cardboard paper. Paper is just with adhesive. Paper is passing through the roller where adhesive is mixing. Two paper at the top glued and the bottom glued. From both sides you just add it and place it. This is laminated particle. Orientation of reinforcing agent. Orientation different types. If you want to fold it, suppose this laminate, if you want to buy from the market, they will roll it. This laminate sunmica. If you go to give me sunmica for my dining table, it can roll. That means the fiber grain in one dimension. Suppose this is the fiber grain. If you have chalk, I can show you. This is the fiber grain, so we can fold it. So this is one dimensional orientation. Two dimensional means here one fiber grain, suppose this form, another fiber grain just opposite form. So this is strengthened all from all direction from the previous one. And 3-dimension means you haphazardly give the orientation. 3-dimension always give a huge strength than among the first two 3-dimension. So during our any composite material, if it is possible 3-dimensional orientation of the fiber, that gives huge strength. You can see that. This is 1-dimensional orientation. This is 2-dimensional means cross. One is here, next is here. So that is 3-dimensional. In any direction, obviously always it is to cross direction, not in one direction. Always going to more of this. When we want to the particle board, during particle board, I am using not any factory. I use some long fiber. Somebody asked me, sir, why you are putting the long fiber? Long fiber is the load bearing fiber. Cantilever, you have seen. It will bear the load. So if you at middle put some long fiber, then the board strength will move. It is just from thinking. It is not say that you must use this. Now foam material. We can use foam inside and from both sides we can use. This is also composite. This is honeycomb foam. Available in the market to make it lightweight. We can use this. Lightweight, suppose for pulsing, you need some lightweight composite material, very lightweight. So you can use honeycomb foam available in the market. And from both sides, you just put the decorative bonding. This is our only composite. Now, I have already told you the fiber grain should be, this is called case, this is called foam. During preparation of plywood, we never root every fiber, every veneer. This is called veneer. How veneer is formed? The veneer when when log is cutting off, after cutting the log from both sides, we are using some point hanging, so it rotates. Any log, wood log, we just cut from a particular side, suppose 8 feet. Then from both sides at the center, we just bind it with the metal. Then the log is rotated. And when log go to the knife, a knife is there, very sharp knife. And that knife, at the top of the knife, there is a lever. So when log come to the knife, the lever is just attached with that. A particular thickness, whatever you measure. So this is our log. So we just fixed it from this. Now log is rotated, and here there is a knife, fine knife blade is there. So when the log is come to this knife, a particular thickness, if you want 2.5 millimeter, if you want 0.5 millimeter, 0.5 millimeter thickness wood, it just like a sari, it moves after here. So you will get a film of wood fiber is going. Nowadays, if the unavailability of wood, I can imagine 0.1 millimeter they are repairing. It is just like a sari, it moves. And there is a machine after 4 feet, it is chopped. Because 8 feet, it is 8 feet and it is 4 feet. 8 feet by 4 feet of press, they will prepare the plant. So this is our, we use the glue, here it is glue hook. This core is glue hook, means two roller is moving. Here at the front top, we are using the glue. There are some hole is there. In this, we are using suppose phenolic resin. So phenolic resin fall on this top and it is mixed with this rubber roller with adhesive here also. When we pass this veneer from this, the both side of this veneer will be glue. The face veneer will never glue. If we use face veneer glue during hot press, there will be a polymeric coating. But in plywood, you never see it is just wood like. So this is glue free. The second one is glue coat. Then third one no glue. Then fourth one glue, then this. So in a 5-layer plywood, we need 2 glue coat, 3 normal. This thickness, 3 thickness are same. This is low thickness because it should be fine surface. So this is costly. Both face are costly. That is why their thickness is 0.1, 0.2. But this you can use 2.5, 2.8, whatever your this year equals. So this is our procedure. So in a 7-layer, we need only 3 glue and 4 are normal. So this is our plywood manufacturing. During plywood manufacturing, there are so many problems arise. First one, delamination. Layer delaminates. Why delaminates? During the passing from this roller, suppose gluing is not. So you have to be careful about the proper gluing. Because gluing is not properly, some portion of this veneer is not good, so bonding will not proceed. Suppose some portion there is glue is more, that glue is more will moisture more, that moisture make a steel pocket there, so there will be steel pocket. That is very bad. So we have to control everything and bending. If you use high temperature, then high temperature, or if you keep the plywood for a long time in hot press, then there will be twisting, warping of the plywood. Another is if resin phase thickness is less or resin is more, then there will be penetration from the face because face thickness is comparatively less, so there will be bleeding through. It make a black patch. So bakelite phenolic resin is black, so black patch on the surface will reduce that. So during composite preparation, you have to be careful about you never use more cement. हम लोग जितना चाहे इसमें डाल सकते हैं, there will be ratio for PCC or RCC, the ratio of the sand, cement. So we have to follow that. And during glue core, if there is some gap, this gap make the composite weak. So we have to be careful. It is overlapping, and one is overlapped by other. So there will be thickness difference, and finally split. It is suppose surface there is not uniform, there are some gap, it differs. So during composite preparation, here is coming. Tomorrow we will prepare not only particle board, some piece of composite also. Now what I have prepared, this is my hand. This composite actually bamboo. I always think it is the best fiber producing in the world, bamboo. So I have prepared this beam in my hand. This beam, this tiles from bamboo. This is the housing system, and this is the truss. Truss means in rural house we need some truss. This is truss we prepared from bamboo. This is our bamboo door, and this is for computer type of door. Though it is bamboo, if you can cover it or you can paint it, no doubt. So this product we can prepare. Very easy to prepare. We have to control the moisture, we have to control the adhesive. So we can use this this material mystery of in Arunachal, maximum women are there. So they are very good means always they are careful with their work. They are mad these people. So with this factory development, entrepreneurship and employment generation for the women, the rural area, it is possible. So it is the another opening of the job in the rural area. So they are engaged, every lady are engaged with this because they are bridal lady and this lady love me too much is now Sudha. Papa now Sudha means owner. Her name is now Sudha. She is the owner of this factory and not only this, she can weave with machine also. There is the automatic machine for weaving this kind of woman and this woman is preparing the plywood also. These are bamboo housing system where in Meghalaya, Sarvasipal region, this is a toilet door. What is the motto? Actually, we have to use composite materials, either reinforced composite materials. This is the classroom inside this. And this is in Kanna Valley. I was there, I was working at the time. It is two buildings I have erected. I have erected more than 130 buildings of bamboo composite. And this is in Kanna Valley. It is 180 feet and another is 204 feet. As I stood of fashion technology for the women. This is the interior part. This is the satellite view of this college is during the fabrication of the composite. And it is our Pronomo APJ Abdul Kalam. He was an inaugural session for Army Center. It is bamboo composite to paints bamboo composite for in Army Center for Army Center. And in Army Center, why it is for Army Center? We can prefabricate this house. House means in company after preparation. It is not an bolt system, just like your hut. Nowadays, in fact, you can open it and transport it. This housing system, you can open it easily and you can transport. So, during suppose in hilly area, some army is necessary extra. So, by helicopter, we can carry this housing system for them. And again, when we not need to stay there, we can open the nut and bolt. So, for disaster management, I also set another project to DST. This is costly composite, and I also send another project for disaster management. Suppose government gives some rice, they give in the house for disaster. So housing system also give in the storage. When there is any flood, we can use this during that because a complete building or a complete house or any house, if we want to prepare, we need long time. But with the cement plate, if it is ready, we can just put nut and bolt, we can use it. That is very low cost, not long. I have said clearly also. This is bamboo housing complex in minus 40 degree. It is double layer. In between this double layer, there is polyurethane foam we have to get because in minus 40 degree, it is very difficult to stay inside at night. So polyurethane foam is the good protect the heat inside temperature in an healthy. So this is in times you uses the word you have to utilize bamboo, you have to support our bamboo. And this is bamboo. It's not whole bamboo composite housing system. It is at Delhi we have injected. It was the cost at that time 8 lakhs, 400 square feet at first floor and ground floor. Total 800 square feet. It is bamboo house. So this is our composite materials that I am also associated with that. In the next session, we will prepare some composite board if materials come here. So, hello. I mean, meeting as. So, some materials are coming from Calcutta for this resin preparation, resin kettle. So, if we come in proper time, we can start. Otherwise, I have epoxy resin. Epoxy resin, you know that it is mainly used in aeroplane bodybuilding. So, I have epoxy resin. jute also, glass fiber also, we can prepare after this session that material in my hot press in idea. Thank you for listening me for a long period of time. I think you have some idea about that, you have acquired some idea, and during the practical work, it will be clear more and more. Thank you all.